Hello, my name is Anand. In this project, I built a machine learning model to predict the net hourly electrical energy output of a combined cycle power plant using ambient environmental data. I used an Excel-based modeling approach and I will briefly explain the problem, feature, model selection, validation strategy, and final evaluation. So first would be like the problem definition and the machine learning approach. The goal of this project is to predict the net electrical power output of a power plant, and since PE is a continuous numerical value, this is a supervised machine learning regression problem. So the dataset contain around like 9,500 plus hourly observation with a 4 ambient environmental variables. That is nothing but a temperature, ambient pressure, relative humidity, exhaust vacuum. And these variables directly impact the turbine efficiency and therefore power generation. Now, feature and output metric. So basically the input feature used in the model are temperature, ambient pressure, relative humidity, and exhaust vacuum. The target variable is a PE measured in a megawatt, and to evaluate the model I selected root mean squared error, that is RMSE, as the primary output metric. So RMSE is appropriate because it penalizes a large prediction error and is commonly used in a regression problem involving energy output. Third, the train test split and validation strategy. So next would be like I split the data into a training and test sets. So 80% of the data is used for the training and 20% is held out as a test set. A split column is added to clearly identify training and test rows, and this ensures that the final model is evaluated on unseen data which help assess real world performance. So during model development, the training data is used to estimate the model parameter while the test data is used only once for the final evaluation. And the next step would be a model selection and training. So for the modeling, I started with linear regression, which serve as a strong and interpretable baseline model. Now this sheet shows the learn coefficient for each feature and the intercept. Each coefficient represents the expected changes in the power output for one unit change in the variable, holding the other constant. So linear regression was selected because it is simple, transparent, and effective for the structured numerical data such as this. And the final state would be like the model evaluation and result. So after training, the model predictions were generated on the test set, and this sheet shows the actual power output, predicted power output, and prediction error. So finally the model performance is summarizing using RMSE and MAE. So the RMSE value demonstrate that the model predict power output with a relatively small error margin, indicating good generalization to unseen data. And finally the conclusion. So in the conclusion, this project demonstrates how ambient environmental condition can be used to accurately predict the power plant energy output using a supervised machine learning. So again, this is an Excel based workflow, include data preparation, model training, validation, and evaluation, fulfilling all project requirement. Thank you for watching.